All right, folks, we'll get started. Hi, everyone. My name is Kamesh Pamaraju. I am your moderator and host for today's webinar. At Platform 9, I work on product marketing and help run some of these webinars that you're attending today. So very quickly, a little bit of background. We've been running a webinar series on the journey to Kubernetes for the past several months. This is a webinar number 5 in this series. We have a few more to go. One of our panelists today is going to go through all the stuff we have covered so far. But today's topic is logging in Kubernetes. Now, Kubernetes makes it pretty easy to manage large-scale containerized apps, but it also introduces lots of challenges. Unlike what you may have in your traditional VMware or VM-based or bare metal environments. Today, we're going to go through a complete process, best practices of, so Rupak, if you can go to the intro slide. We will have a quick introduction to the panelists, and we will go through a quick recap of this webinar series. And Peter has been walking our audiences through what it takes to really get Kubernetes into production and all the steps that you have to take. And the main topic for today is logging in Kubernetes, and we'll have this in our usual style, fireside chat between Peter and Rupak, and then we'll have a couple of use case examples, and then we'll end with Q&A. And feel free to ask questions along the way. So we do have the Q&A button that you can press, or even feel free to use the chat window. I'll moderate and look through the questions and ask them if they're appropriate along the way. Next slide. So as usual, we have been giving away these special prizes, if you will. We appreciate you joining us today. We'll be giving away one online Kubernetes course from our learning partner, Learn K8s, and we will announce the winner from the draw at the end of this webinar. And keep in mind, there's a giveaway for every session. So if you're into Kubernetes, learning about Kubernetes, Learn K8s is a great partner where you can learn not only just the basics of Kubernetes, but also advanced stuff. Next slide. And for today's speakers, we have two of our most experienced technologists on the panel. Peter Frey runs our solution engineering team. He's the field chief technologist, lots of experience. He's going to go introduce himself shortly. And Rupak Parikh is our co-founder and CTO at Platform 9. So folks, I'm going to hand it over to Peter and Rupak to kind of do a little bit broader introduction and then dive into the topic for today. Thanks, and keep those questions coming.
Great. Hi, everybody. My name is Peter Frey. I'm a field CTO here at Platform 9 Systems. I run our pre-sales and post-sales teams here at Platform 9. I've been with Platform 9 for a little over 3 years now, and I get this opportunity to talk to many of our customers, many of our prospects that are on the journey to Kubernetes. And I hear a lot of themes on what that looks like when people are trying to adopt Kubernetes and what it means to their organizations. And so this gives me a great forum to share some of that, of those, what I learned from those different customers as I talk to them. So today we're going to talk to you about logging and how critical that is and what it means to do logging in Kubernetes and how it's different. So it's going to be a good, exciting talk. Rupak.
Thanks, Peter. Hi, everyone. My name is Rupak Parikh. I'm one of the founders as well as CTO at Platform 9. Over the course of last 3-4 years, since we have been shipping Platform 9 Kubernetes, we have experienced all kinds of customers, all kinds of issues. So happy to be talking about that, and specifically in context to logging and how some of the work that we did and some of the tools that are available has actually helped us go through this journey. Over to you, Peter.
Thank you. All right, we'll jump forward here. So what I've been doing, the reason that we have this whole journey to Kubernetes in production is the whole webinar series, excuse me, is because, when I talk to our customers, they're trying to figure out, what does it mean? What is Kubernetes? Why should I do this? How do I get involved? Who gets involved? And they're trying to figure out what it means to their organizations, right? So I talked to our marketing team and suggested this, how do we get to Kubernetes in production series for our customers? And so just a kind of a brief discussion on that journey, right? When I talk to people, it's enterprise architects, sometimes it's developers, sometimes it's people in the office of the CTO, right? Sometimes it's SREs, right? All kinds of different people are taking avenues into figuring out what Kubernetes means to your particular enterprises, right? So as they start this process, they usually go, all right, well, let's deploy a Kubernetes cluster. Then they start making decisions and they Google things, right? Do I want to do it on the cloud? Do I want to do it on-prem? What's this going to cost me? What do I want to do it in VMs? Should I use it? What CNI do I use? And all of these are topics like, well, how and where, and what's the process and that sort of stuff. So that they go down the path. Eventually they get a Kubernetes cluster up and running, and everybody deploys the Kubernetes Hello World or Nginx as their first app. And that, that's pretty exciting. But what happens then is they go, okay, that's great. Stateless apps, they work great, but how do I deploy something more interesting? So most of the people I talk to deploy something like a WordPress, right? It's a little bit more complex. And this is the first app that I actually deployed after Hello World because I wanted to see what happened. And the very first thing that did is it failed. The Helm deploy failed on me. And I needed to figure out persistent storage, right? How do you do persistent storage? Why is that different? Can't I just attach a drive? All kinds of things came up in my mind, and I ended up figuring out how to do storage in Kubernetes, created that default storage class, and then I was able to deploy WordPress. And a lot of our customers go through that same thing. So they get this cluster, then they figure out persistent storage for the apps that require it. Then they move into well, we're ready. Let's start taking a run at a corporate app, maybe a tier D, something that isn't mission critical to the business, maybe doesn't have a lot of revenue generation as it, and they start to figure out, well, how's this thing deployed? How is it Dockerized already today? How do I Dockerize this? Why do I have to do that? And then they start figuring that out. And then they say, okay, I got this thing, it runs in a container, and they get it and they start deploying it, right? But as they move through this, then they go into the phase of, well, if this is going to be a production app, we need to do things like monitor this app. But how do I do monitoring in Kubernetes? It's different, right? Do I want to use Datadog? Do I want to pay for a service? Do I want to use kind of a CNCF standard with Prometheus and Grafana, right? An alert manager. There are many other tools out there. So they start Googling and they figure that out and they do that. Right after the monitoring, or sometimes before the monitoring, comes in the logging, right? And again, this is a phase where, okay, I need to capture logs. Well, what's unique about logs inside of Kubernetes? And there's a lot. And Rupak and I will talk to you about that in a minute. What options do I have? When you start Googling Kubernetes logging, you find out there's things like the ELK or the EFK, Elastic, Kibana, and FluentBit. There's things like Loki. There's things like Splunk, right? And they're all options and they're all great and they all work. And you just got to kind of pick the one that you want to go with. And we're going to discuss a little bit on, which of these we use and why when we get into that later in the day. But as we move into this, beyond that, then our customers are looking at how do I continuously integrate and continuously deliver so I can get some of the benefits of having Kubernetes inside my environment. Do I want to use something like Jenkins X or Spinnaker? And by the way, all these steps, they're Google, they're research, they're testing. Sometimes it's I deployed something, I didn't like it, and I start all over and redeploy another Kubernetes cluster and start out again. So it's a cyclical process. It often takes months to get through this. From there, how do I do A/B deployments? Do I want to use Istio? Do I want to do Linkerd? A lot of our people I talk to, they just want to get it repeatably deployable. We move into how we're going to deploy this, and a lot of our customers skip the A/B deployment part of this. And then how do we get into information security? If this is a production environment, how do we do identity management, et cetera? Then they think they're ready, and we're getting to where the logging comes in and why it's important, because as soon as you start thinking about day 2 operations, logging becomes a critical path, right? So how do I upgrade? How do I manage it? What happens when I have my first production outage? So when our customers have deployed a app, they're starting to run it in production, and now they have their first production outage. This is when things start becoming interesting and when logging becomes absolutely critical, right? So Platform 9 had a real production outage. when we were developing our free tier, which runs in Kubernetes, and we do have a free tier. Hit our website, and you can go try out Platform 9 Managed Kubernetes for free. We had a serious outage. We were starting to see Kubernetes nodes not ready. We didn't know why. We dug in, nodes were not ready, jobs were failed, APIs were errors, API 500 errors. The ingress was up, and that was good. We tried to SSH to worker nodes. We couldn't because the machines were locked. Our reaction was to build better monitoring. Our chief architect, our CTO, Rupak, who's on the call here, dedicated many weeks to trying to solve this problem, right? And so we did node optimization so we could actually reserve memory on those boxes, so we could actually get into and view logs, the kubelet log, the API server log, application logs, right? And what we realized is that we have to do a better job of dealing with logging and having it in a centralized place. And we'll get to more on that in a second. So this worker node went not ready again. Kubelet failed. The application APIs are still failed. We started implementing Kubernetes limits, mission controllers, default limits for 80% of our pods. Other pods had more limits on the specific pods. Cascading effect, one node would go offline. Kubernetes moves the pods to other nodes in the Kubernetes cluster. Another random pod would go offline, or node would go offline. And we were in a bad place, right? We ended up killing and redeploying the thing. But as we start digging into the logs for this worker node's not ready, we found, that the worker node was not ready. And the reason for that was kubelet was not ready. And the reason for that is the pod lifecycle event generator was unhealthy, right? And so it turned off kubelet, right? And so then, we're during this whole period of time across 13,000 services running on top of Flannel, 6,000 pods, 5 masters, and 79 worker nodes, and millions and millions of log line entries to do this. Platform 9 realized that we have to have a solid solution in place for collecting the logs, collecting them in a single place, and being able to access them and correlate them. So we spent, I'll just talk about this box here, right? We spent hours and hours and hours by very expensive resources on our teams correlating these logs. Not only was it timestamps, it was looking at a log from this API server or from, this application log as memory is being consumed over time. And we had to correlate all that together to try to figure out what was important. So we realized logging wasn't set the way we needed to do. So again, this is the topic of today's environment. Right. And for a lot of our customers, the answer to all of that is a managed service, simple decisions around Kubernetes deployment, monitoring, logging, CSI, CNI, CI/CD. And this is all in the Platform 9 offering, but we'll kind of skip ahead on that and jump into our Fireside talk. But real quick, so as I mentioned, we had our intro to the series. We had a couple of different networking ones. We talked about storage. This is our logging one, where we're going to dig deep into what's happening with logging and what's happening in the industry around logging. And then we'll have 3 more after this, pipelining, deployments in production environments, maintaining Kubernetes, and best practices. So Rupak, maybe you'd like to spend just a second and expand a little bit on some of the log challenges that we had when we had that production outage from your perspective, because you lived it, right? How challenging was it to gather those logs? How challenging, what do we do to kind of circumvent that, and why?
So one of the things that all of us realized when we started on Kubernetes, and this was even before the outage, was Kubernetes is different. Containers are different. There are a bunch of microservices running on many different nodes, and just correlating them, trying to find the issue is finding needle in the haystack. So unless you have a logging solution which aggregates all the logs in one place, and I'm going to talk a little bit more about it, it is almost impossible for you to figure out what really happened in the system. And there are also different kinds of log. It's not your applications. Kubernetes is also there. And as a Kubernetes company, we have to, as Platform 9, we have to look at all the systems logs, obviously, to make sure that the system is up and running. But having a reliable log aggregation system which can get you all the logs from the system as well as the containers, and they're able to look up and down the stack was absolutely crucial. Without that, we couldn't have solved the problem. And when we started our journey, we didn't had anything, and it took ages to figure out and catch the problem at the right time to see the issue and to see the logs at that point of time. But as soon as we put in the log aggregation system, we could for minor problems, the problems would happen on the weekend, and we can come on Monday and go back and check it out and correlate issues from one container to another container to even in some cases Linux operating system. So you're able to correlate that and get to the bottom of it. So it was super helpful.
Rupak, what kind of options do people have when they're considering consolidating logging, inside of their Kubernetes, for their Kubernetes clusters?
There are lots and lots of options. If you just search Google on Kubernetes logs, I'm pretty sure there are at least 10 companies who have commercial offerings. It's hosted, non-hosted. You can host yourself. There are open source alternatives out there. And I know, Peter, you have a slide on that. Maybe we can talk in more details, but there is no shortage of options. It really depends upon what your organization has, whether you are inclined to use open source or commercial, whether you want hosted or you want on-prem for security reasons, so on and so forth. So it all depends upon your situation and your organization.
Rupak, when we were going down, we had these outages and we realized that we needed consolidated logging. How did we make the decision on what to use, right? What did you look at?
Oh, well, we started with, and I'm smiling because in the course of our Kubernetes journey, we actually went through, I kid you not, maybe 3 or 4 different logging solutions. We used a couple of hosted solutions, and we will talk in a little bit more detail about why we chose not to use them. Then we also started looking at a couple of open source alternatives, and then we, towards the end, we decided on using EFK. That's our current logging stack. And I know, Peter, you have some pretty interesting Git repos that you can point to people where you can go and actually deploy it by yourselves. But as I said, it depends upon various factors, whether you want to use open source, deployed by yourself, do you have the people to maintain it? There are things like log retention, security, obviously, bandwidth. There can be tons and tons of logs at these containers. It all depends upon your application that they spew and the logging level you are at. So there are lots and lots of challenges, but all of those are solved problems. There are alternatives, but the specific solutions that you want to use, it depends upon your own situation.
Hey, Rupak, there was one question that I think is relevant here. One of the participants is asking about embedded systems having very strict resource constraints. And obviously, they don't have enough storage or enough performance. How is the industry embracing Kubernetes in an embedded environment, especially from a logging perspective?
So we have seen many examples of people looking at Kubernetes for their small size deployments. We have some customers who are using us in real-time operating systems. And all of these places, they have to use some kind of monitoring system, whether it's metrics or logging or a combination of both of them. And in some ways, Kubernetes is actually a lot easier to configure. And when Peter spoke about some of the challenges that we had and the plague and some of the other issues, one of the things that we did, and anyone can do it on Kubernetes, is make sure that you give enough resources to your logging agents to make sure that they do not go out of bound. And so there is a balance that you need to have. You may not be wanting to, specifically in production, you may not be wanting to ship everything out to your log aggregation system. And you may want to just restrict it to like error or fatal logs and have your logging agent be constrained in terms of the CPU and the memory it can, and the disk space that it can use. So there are ways to constrain it, and it's possible to do it, but it does require a little bit of work.
Thank
Okay.
you.
Rupak, just real quick, on the scale of logging in the environment that we had, which is what, was it 85 worker nodes and 5 master nodes? How many logs are generated from that?
A lot, a lot. I would say a few gigs per hour, or maybe a couple of gigs per hour to maybe a few gigs per hour. And it all depends upon, so we have a bunch of containers, and when the request comes in, we log more, and in the nighttime, it goes down. But overall, it can go to like 100 gigs per day. We have seen that. So it can accumulate very, very fast.
Did you
And
say
that's on the lower side. And that's on the lower side. We have seen in some of our customers, it can go even higher.
so? Did you say 100 gig per day?
Yeah.
Yeah, that could be a massive troubleshooting challenge there if they don't have the right tools in place.
Yeah. And that's where the earlier point about you need to figure out what you need to log, and there are other dimensions to it, whether you want it to be searched or not, because then you have to create indexes, like Elastic creates indexes, and that's great for searching, but it means you're also generating lots of index data associated with it. So there are challenges associated with that too, and I know some of that we are going to cover in some of the slides. So let's get started. I would like to go back, like step back and talking about why do we even care about log aggregation and logs accumulation. Let me go back maybe 10 years ago when this whole debate started about pets versus cattle. When I started my career, where we used to have servers, and the administrators would actually talk about how many days the servers are up. They really felt proud of their servers and how long they were up. In fact, I spent quite a bit of time at VMware, and we used to have this metrics, and we used to talk about folks in our customer base who would say, my server hasn't been restarted in 3 years or 5 years, so on and so forth. But those days are over, and people don't want to have those servers running unless and those don't want to have those servers running for a long time. They actually want to treat them as cattle. The server are mostly stateless now. All the configuration is kept outside so that you can actually take the server down or add more as needed. Most of the services are microservices. You want to be able to scale out as needed and scale in as needed uh, depending upon your use cases. And so in the in the time when we were treating servers as pets, the logs were on the servers, and log aggregation at, at that point of time was more of a luxury. But as and when our computing needs have risen, and we have many servers, um, we have distributed services, and those servers can go up and down. The logs may not be on those servers, so it's important for them to aggregate it to one place. So that's one kind of transformation our industry has gone through. Next slide, Peter. More than servers now, when we started with servers and then we moved to virtual machines, virtual machine had somewhat a similar look and feel and tooling associated with VM as with servers. So you would treat your VMs as servers, uh, everything from backup to systems management. They were essentially treated the same. And there was no cultural change in how we dealt with virtual machine on versus how we dealt with physical servers. And again, even at that point of time, I remember the log aggregation was still a luxury. But as we move into the container world, which is more microservices world, which is fueled by microservices, you have containers which are just really processes. And these processes, there are many more, and there are hundreds and thousands of them. Containers are immutable. That means anything that you write on container file system will get lost as soon as you reboot or restart the container. And so you cannot really keep the logs there. And you have, as I said, one process per container. So instead of one virtual machine running 100 processes, now you have one process per container, and now you have hundreds of container, and each one is logging into a different place or different node altogether. So that has its own challenges. On top of that, because of this architecture, some of this container runtime, they decided that, you know what, forget application taking on the logging, container runtime will help with that. And so they have their own nuances associated with it, which we'll talk about next. Next slide, Peter.
Rupak, you brought up that logs are contained within the containers. I think this is worth of highlighting, right? If Kubernetes moves a pod, which moves the containers to another host, what happens to the logs at that point?
Those are essentially lost. I think Kubernetes keeps one version of the logs for a particular container on the file system, but if it moves away, it will essentially get lost. So if you come back, as I said, 2 days later, or maybe 20 minutes later, you essentially lost the log. So it's not a luxury anymore. You have to push it to a central location.
So
And
in other words, when we were having our outage and worker nodes were going offline and pods were getting rescheduled, if you're trying to understand how is memory being consumed or what's happening within the application, and the logs are on one container and one server, and now they're on another container and another server, that correlation must be just a huge challenge.
it is. And even without the logs going or without the containers going away, think about a microservices architecture. You have your load balancer, then you have your ingress controller, which is your HTTP or HTTPS endpoints typically. And then you have 3 or 4 or maybe tens of services behind it. And your UI or your API clients are hitting each one of those. And sometimes they get data from all of those and then present you what you see. Netflix is a classic example. There are maybe hundreds of services running on that behind that Netflix page. And imagine if one of those goes down, the person who is trying to debug it, he needs to go and say, okay, what happened with the HTTP request? Hey, did it land on my service A? Did it land on my service B? What information that they're giving out? And the time correlation associated with them, and their interdependencies. It's not just UI or API clients talking to service A, service B. Service A, service B may be talking to service C and D, and they're all independent. So microservices are great. You can update them, you can scale each one of them, but debugging is actually in a lot more ways, it's very, very difficult. And like you said, it's impossible unless you have a system where you can see everything together. To that point, you spoke about some of our clusters that we have seen, and we have seen really large clusters, 200, 300, maybe 500 node clusters. Some of our, I would say, typical size clusters are maybe 50 to 100 node clusters. Each one of them have, if not hundreds, if not thousands, at least hundreds of pods, depending upon the size of the pods or containers that you're running. Some of them have one or more processes associated with them. And as you can imagine, the number of logs sources just multiply. So if you're looking for 100 into 1,000 pods, you're talking about 100,000 sources of logs, and just traversing between them manually is impossible. So you have to use you have to use something like a log aggregation so that you can aggregate something and then look them through. Can you get to the next slide, Peter? So I wanted to spend maybe a quick minute talking about at the lowest level how you can look at the logs, and then we'll talk about Kubernetes, and then we'll talk about some of the other tooling that we have seen. So specifically with Docker, which is probably the most important runtime that Kubernetes uses, and then probably you're using it in your developer environment. You're probably using Docker in and out every day as developers or DevOps folks. One of the ways Docker helps you generate logs is through what they call as a logging driver. So if you don't want to be running Kubernetes, if you're just running Docker, you can just configure Docker to log log all of your container logs into a central place. And I'm showing on the right-hand side couple of settings. You can log it to syslog, AWS, Splunk, Google, FluentD, JournalD, and so on and so forth. So there are lots and lots of options there. And Docker's website has really good documentation on how this can be this can be dealt with. All the logs are typically in this var log Docker container, some ID, and then you will have the log in that directory. It's important to know this because regardless of the vendor that you choose, most of the vendors who support Kubernetes, they use Docker underneath it. And if you don't have an aggregation system, this is the place to go and look for the logs.
That's on each machine.
On each machine. Thanks for noticing that. Next slide, Peter. So if you look at Kubernetes, it's even more complicated. So I've tried to divide it into about 3 categories. One is what we call a system log. So system logs are everything to do with Kubernetes. If you are using your own Kubernetes distro, using KOps or kubeadm, depending upon the tool that you use, the location of the logs will vary. Most of them are in var log. With Platform 9 Kubernetes, they are all in var log pf9. We have a specific directory called as kube and everything underneath that. But depending upon the role of the node, whether it's master or worker, you will have to look at the API server, the etcd, the scheduler, the proxy, and if you're on worker nodes, you have to look at the kubelet log. And all of them, to some extent, are interesting. To some extent, they may or may not be interesting. For worker nodes, it's important to look at the kubelet log, specifically if you're running into situations where Kubernetes is not behaving. Obviously, with Platform 9, we take care of it, but if you're running it by yourselves, you need to make sure that you have those. And it's important because some of the problems that you will see in application may be because of the issues inside the Kubernetes itself. So that's one. Then there are other interesting things which are not classified as logs, but they are very, very important, and I highly recommend that you look at it. One of them is what we call as events. Events are, as the name suggests, they're events. They're important things that are happening inside the Kubernetes system with respect to the node or the pods or deployments or services that you're creating. And so it's a constant stream of information that you have, that you can push through, that you can push through to your log aggregation system. Excuse me. And then very similar to that are the audit events. The audit events are really request response, and there are many levels of it that you can configure. I'm showing here as the default policy that you can have. And again, audit events are generated by Kubernetes. They can be pushed to a log file. And once they're pushed to the log file, you can actually push them using some of the techniques that we'll talk about in future slides to your one place. And Peter, I know you have some customers who are very specific, or they are very sensitive about their compliance efforts. And I know they have asked for, hey, how can I enable audit for everything, or all the whatever their consumers are doing with Kubernetes. And some of these tricks are very, very useful, or some of these things are very, very useful in that regard.
So Rupak, the Kubernetes systems logs are pretty critical, right? Because in the old days of a VM or a host running an application, I could SSH over, I could look at the logs, I could look at var log messages, I could look at syslog, I could look at application logs that are all inside of there, right? As it turns out, in the Kubernetes environment, even some of my customers today, and from our experience, right, with the outage that we described earlier, they're very close. The application logs, can't just rely on those. They're very closely related to the Kubernetes logs as well, right? Because Kubernetes could be doing stuff like shutting down leak plague, shutting down a kubelet, right? And then therefore working on going offline, which is impacting your applications and rescheduling and things like that. And that's because your application started consuming more and more and more and more memory, and it consumed all the memory in the box and pretty much locked up the whole box, right? So it's very important to have not just your application logs, but also your Kubernetes logs, so you can correlate kind of what's happening as to why it's happening and that sort of thing. Any thoughts there?
No, absolutely. And like you said, Kubernetes is it's infrastructure, but it's also very close to application. You can think about it as a lightweight platform as a service, and you will see implication on your application if your uh, platform service is not running. And like you said, Peter, if kubelet is not running, it may actually go and not shut down, but drain all the pods from a particular system because it cannot go and connect to your masters because it's running out of resources. So there are implications on what can happen. So you cannot completely ignore system logs. In fact, you should put system logs in a central place. Again, look at the number of nodes some of our customers are running, 500 nodes. And it's impossible for you to even go and figure out where the problem happened, when it happened. Unless you have a system where you can put everything together, you won't be even able to debug the problem and even configure it later on once you learn from it.
Rupak, Ravi asked, can you persist volume? Can you persist volume strategies to persist application logs? I think he's asking, can I use application logs to be stored in persistent volumes inside of Kubernetes? And I think the answer is kind of maybe, depending on where the logs and how you're doing your logging and what you're using as a tool. But I don't think you could use things like kubelet and that for inside the Kubernetes cluster. But what do you think?
I think that's what you said is correct. So I think that strategy will apply to the logs for containers, but not for the system logs. Absolutely. And I will talk about that in the next slide or rather, I will talk about the different logging strategies that containers can use in a couple of slides. So let's talk about the application log quickly, and then we can go to Ravi's question in a little bit more detail. So we spoke about how the system logs are kept in Kubernetes. We spoke about events and audits. Now comes the application, the thing that you are running, the applications that you have written. As I mentioned earlier, containers are supposed to only write to std out, and the container runtime, Docker, or others, container D, they will take out that std out and then push it to the log files and in some location, depending upon the runtime. For Docker, it's varlib, Docker, container ID, so on and so forth. And so that's one. But if you're just testing Kubernetes and you don't have log aggregation systems, instead of going to each node to figure those to get the logs, which sometimes you have to do, you can actually use something called as kubectl logs, and you can just give the pod name. That's how we started. Peter, when you were describing what are the things that we did, this is how all of us, anyone who starts with Kubernetes, that's what we do. You just go to the pods and say kubectl logs and the pod name, and then here comes the log. But as you mentioned earlier, they will be lost as soon as you restart, or the Kubernetes decides to relocate that pod. So be aware of that. Next slide, Peter. So let's talk about how an application which is running inside a container or a pod can log to different backends. Because so far we have established that it's important for us to push the logs to a log aggregation point. So the very first thing that most people do, and when they're coming from or they're migrating their applications, which are probably running in virtual machines, to container, is let's put all the processes inside one pod, and then we have the agent from Sumo Logic or Splunk that is part of that particular container, and then we will push those logs which are written on the container disk to the logging backend. Now, even though people may start with it, I have not seen it in any kind of production. So even though I'm mentioning it, this is not very typical. and I would not recommend it. Let's go to the next one. So this one is an interesting one. When Kubernetes started using the term sidecar, I laughed, and this is the image that I had in mind. So this is a sidecar logging. So sidecar, for people who don't know, a pod in Kubernetes is really a container that shares the network and other things with that particular with other containers in the same pod. So they are co-located. So the two pods, so the two containers in one pod will always be co-located. So this is one way by which you can run multiple processes or multiple containers which want to talk to each other in one pod. So there are two ways of using this particular pattern to log. So I spoke about how you can have your Splunk or Sumo Logic and or other agents that you have to push to the logging backend. So that's very first one, where instead of having multiple processes within one container, what you can do is you can have the container for your agent as another container which is running in the same pod, and that streams to your logging backend. Okay, this can be a little expensive because now what you're doing is this agent, and there was a question about embedded systems, and these agents, remember what these agents do is they take the logs, they buffer some, and then they push it to the logging backend. So the resource usage on for each of this pod, because of the agents, will multiply with every pod that you run. And remember, we have seen our customers run thousands or tens of thousands of these pods, and things will multiply very, very quickly. So if each one of them is using, let's say 50 MB, just imagine how much it would be if you keep on accumulating on each node and throughout your cluster. So suddenly your computing and memory resources needs will increase. But that's an option if you're starting, and in some situations it may be worth it. So the other related one for sidecar logging is instead of and this applies in the situations where you're probably porting applications from your VM-based work setup to containers, and then you have your applications writing to var log XYZ. They're not writing to standard out. Okay. So how do you get those logs from those container file system out to the container runtime so that you can use some of the other agents on the node that are running that can grab that log and send it to your logging backend? And this is a pretty interesting pattern that people use, where they run as another sidecar, and all that does is just tails the log on the container, your application container. So let's say your application container is writing to varlog, let's say platform9.log file, and then this your container log will say tail minus f varlog blah blah blah, and when it does it, all those logs are captured on the disk, and then the logging agent picks it up and sends it to the logging backend. So that's another way. And then the third way, next slide, Peter, is having the agent running on each node. And there are lots and lots of people who have done this. Most of the vendors have an agent that can be deployed as Kubernetes daemon sets. So use that. These daemon sets will run on each node. They will talk to the, they will look for the Docker directory or the runtime directory, grab the logs which are produced from the standard out of each of the container, and then push it to your logging backend. That's the most important. That's the most popular one. I would recommend that you use it. That way you can also go and restrict how much buffering these log agents can do. You can also do a lot of interesting stuff. For example, we use FluentBit, and you can have patterns on the logs that you want to capture, the logs that you want to exclude, the log level that you want to exclude or include. So there are lots and lots of filtering that you can do at this level so that you can keep the amount of logging to the backend optimized to what your needs are. Next slide, Peter. So once you have figured out the logging architecture from your application side, then really you're looking at different aspects before you choose what system to use. And some of these things that I have laid out and I spoke about earlier. So the very first one is, should you use a commercial and open source? And again, it depends upon your team. At Platform 9, we said, okay, your applications are portable and we use open source and we want to promote open source. So we said, okay, logging should not be any exception. And that's what we picked. But you may already have things like Splunk, Sumo Logic, Datadog, and so on and so forth. You can also use them. It will probably save you time because it's already there. And maybe you have other applications which are not running in containers and you want to correlate all those logs. That's another reason you may want to use an existing logging solution. One of the big things that we did, and I wouldn't name the vendor, but we had issues with the logging agent taking up hundreds of MBs on each node. And in fact, that memory usage was more than any of our applications. So you have to be a little careful with that. I would suggest you run it at scale and figure out what's good for you. The other one on open source that I would highlight is, instead of using FluentD, use its close cousin called as FluentBit. It's much more performant. And we started with FluentD, but it wasn't able to keep up. Specifically, the memory usage was very high and the CPU usage was high. So we moved to FluentBit and we have been very happy with it. So that's another thing that you should look at. The one important thing, and Peter, please feel free to chime in, is the retention. And if you are looking at commercial or even open source software, the logs, as I said, can grow very, very quickly, how long you want to keep them. And if you're using an indexing or non-indexing solution, whether you want to keep those indexes or not, that's going to be one of the big decisions that you will have to make. And it's all depends upon the resource that's available to you, the cost associated with it, and obviously how far back you want to go. Peter, do you want to add?
Yeah, from a troubleshooting perspective, I would think recent history is probably the most important. And when you're troubleshooting something, typically you're not going back a year in time to figure out what's happening there. So archiving some of the logs, I think, is very important. Rupak, maybe you can expand on how long do we keep logs for troubleshooting purposes? And do you have an idea of what level we're keeping them? In other words, do we do any aggregation of logs as we're archiving them and things like that?
Yeah, we do. So what we have done is we use EFK. So we push everything to EFK. And then in the EFK, we only keep, I think, a week's worth of data, 5 to 7 days, I think. And so that you can quickly search through that. But everything which is older than that, we push it to S3 for at least a year. And depending, and this all depends upon whether it's customer data or our data.
Yep.
So we keep that for 1 year and we just archive it. We hardly look at it. At maybe in last 3 years, we have looked at the S3 archive once because we were trying to debug some situation. But most of the time, that the last few days is, as you said, Peter, is the most more important one. Another reason to archive is really from compliance perspective. We and other companies are going through probably security compliance, and it's, I think, important for you to keep some of those and obviously destruct them as well once you don't no longer need them.
Folks, quick time check. We are at 10 minutes at the top of the hour and a number of questions coming up. Just wanted to see how many more slides you've got.
Just a few more.
Okay. Go ahead, Peter. I think
this next topic is really important, though, Rupak. Storing logs locally within the Kubernetes cluster. So I know I deployed my first Kubernetes cluster. I did a lot of stuff with logging. I ended up with the Elk stack as well, Elastic Kibana and FluentBit. And one of my thoughts is it was useful. Then my disk filled up, and then I stopped getting logs, and then my Kubernetes cluster crashed, and I didn't have the ability to manage that. So that was problematic for me. So what's your thoughts, and what are some of our learnings at Platform 9 on storing them in the cluster or versus in another cluster somewhere else?
That's a very interesting point, Peter, you made. And this applies to not only logging, but also metrics collection and distributed tracing and so on and so forth. Specifically in production, I would not recommend you to log inside the same cluster. You shouldn't have your monitoring system run on the same infrastructure that it's trying to monitor. Create two clusters, one for your monitoring, and it can monitor the other clusters and the associated applications. And that's a practice that we follow, where the infrastructure for monitoring logging is different than the infrastructure that we are trying to monitor. And if you want to run that, and if you want to run your EFK stack or Loki or others onto a cluster, make sure there is something else that's also monitoring. So make sure there is redundancy. Otherwise, as you said, if your cluster goes down, the thing that is supposed to monitor it will also go down with it.
So jumping in here on some of the suggestions here, right? There are lots of options out there for logging solutions, right? Splunk, I've used it a ton. I love it. It's got a great user interface. Last I looked at them, they charged per gig, and it was a very expensive option, but I think it's one of the best out there, right? Personally, I've also used the Elastic, Kibana, and FluentBit, and had great success with that. And it's very easy to search and very easy to index, and it's fast. But then I found myself in the business of maintaining indexes and looking at disk space, and I sort of felt like a DBA when I was doing that. And this is also one of the most important things. So do you see, Rupak, that in large environments that they have a logging team that's dedicated just to this, or how do organizations do that?
So depending upon it changes from organizations to organizations. And one thing that I would say is make sure that you have logs for all parts of your application in one place. So if you have database which is outside of Kubernetes, but some applications are running in Kubernetes, make sure that they're in one place so that you can easily correlate them. Other than that, I think it all depends upon your organizational structure and what tools you're using.
A related question, Rupak, for application logs and system logs and other container logs, this is based on the retention period you talked about earlier. The question is, should we maintain different log retention periods for different logs?
Unless there are compliance requirements, I will just keep them the same. And that's what we have done. It's easy for us to debug up and down the stack. So I will just go with that.
Okay. You mentioned distributed tracing briefly, Rupak, or maybe Peter. Can you talk a little bit more about what, if distributed tracing is being used, then does that require additional logging? And what do you recommend there?
So depending upon what distributing systems you use, they typically have their own backend. The amount of data is somewhat different. Logging is probably the most, and distributed tracing doesn't accumulate that much. But that's typically as a completely different system, and I would keep that separate because distributed tracing, you're just trying to look at the performance issues. Logging is more to do with compliance and debugging functional issues. So they are different kind of data. So I will keep them separate, maybe with a smaller retention time.
Right. And on the on the actual disk I/O and network data or logs per node, how do you drill down without having to go into each node?
Yeah, I think that's probably a separate topic, but and I'm not sure whether we already had this or not. But things like Prometheus, Datadog, other monitoring systems would actually help you with each process and container associated metrics.
Yeah, but they also, Rupak, don't they? The centralized logging things like Splunk and Loki and some of these things, they tag and enhance the data that's going into the logging, so you can say, oh, it's this pod and it's this node and this kind of thing.
Yes, you're right, Peter. And some of these systems, as you said, Kibana and Grafana are, and maybe some of the commercial solutions like Splunk and Datadog, they also have both of those systems inbuilt. And what they typically do is these agents actually annotate the logs as well as the metrics with which pod or namespace or node they belong to. So it's easily searchable.
Yeah, very, very easily pulled up, right? And it's all in a centralized location. And it also correlates timestamps for you too, right? Usually
That's very, very useful across logging and monitoring
So
if you're
on the
trying to specify.
timestamp, so if servers are located in different time zones, how
Mhm.
is that handled?
So first of all, I wouldn't recommend that. You should use the same time zone across all your servers.
UTC?
And UTC is
Yeah.
by default what people use.
Mhm.
And these logging systems like EFK and all the commercial solutions that I've seen, they are actually pretty intelligent. They identify the timestamp and will actually parse for you, and you can actually have filters. So and typically most of them will actually let you only look at a particular time anyways. So that's typically a non-issue.
Right. We mentioned a lot about centralizing your logs and all of that. So the question is
Mhm,
about sending the data to the central location. Doesn't that
mhm.
create a bandwidth issue, especially if there's a lot of data and a lot of clusters that are being managed?
Yes, it can. And more than the bandwidth issue, bandwidth is probably okay. Uh, Most of these networks nowadays are like 10 gigs plus. So that's typically not the issue. Retention and the amount of log that you're pushing and the noise it creates is probably a bigger issue. And as I mentioned, all of these have some kind of filtering mechanism by which you can tune it. So you can say, I don't want the system log to be at the debug level, or I want XYZ application log to be at the debug level, so on and so forth. So that's how you will control it.
Got it. A lot more questions coming in, folks. We'll see if I can. We have only 2 minutes left. Let's see. There's a question about how many days logs are held by parts by default.
So by default, Kubernetes does not actually have a log rotation policy. You have to configure it. Some of the vendors like us, we do configure it. So it all depends upon what that configuration is.
Right. Would also love to hear about sysdig. Any thoughts on sysdig? Any experience with that?
So I'm not sure if they have a logging solution. I'm not terribly familiar with them, but I do know that they have a pretty good monitoring solution.
Right. Okay. Did you want to cover this last slide? And then there's just one more
Peter,
question I'll take after this.
Yeah,
Peter.
just very quickly, a quick 30-second platform mind commercial. Right, we offer a complete platform around uh, platform mind managed Kubernetes. We deploy where you want to deploy, on VMs, on bare metal, inside of KVM, virtual OpenStack environments, in cloud providers, AWS and Azure. We can deploy distributed across multiple geos and environments. We're in a lot of 5G space where we deploy in the cell phone towers, Kubernetes clusters, right? We've got great, we can run VMs inside of OpenStack, also inside of KubeVirt, inside of virtual machines. We automate bare metal, so we can deploy in remote locations the server, the OS, and configure it for a Kubernetes cluster. Uh, you know, a lot of this was all about observability today, and specifically Fluentd. We have out-of-the-box options for load balancers, Prometheus, Alert Miner, Grafana, logging, right? If you're into the high-speed networking stuff and have requirements there, we support Maltus and SRIOV and DPDK and Calico and OBS. Also, we have our cool Kubernetes repo. So real quick, if you guys went to platform9.com, you can sign up for Platform9's free tier, right? And then if you want to try out some of the logging stuff that Platform9 offers, we've got a pretty detailed, remind me later here, GitHub repo called github.com/coolkubernetes. If you log in here, one of the tagged ones is logging. Inside of there, we've got a Fluentd operator, which will walk you through everything you need to do to leverage the Platform9 free tier and deploy the EFK stack completely. It'll give you copy and paste kind of directions on what you need to do, how you need to run it, and you'll end up with Kibana up and running with all your logs being generated and gathered in one place. You can search on labels, right? Things like, this Kubernetes pod or that Kubernetes pod or this namespace or that namespace, and can filter these things down really nicely. And it's all available for free, so I encourage everybody to try that out.
Yeah, but just over 1 minute. I do want to announce the winner of the drawing, folks. We have Joe Kaiser from Data Robot, who won today's prize. And congratulations, Joe. We will be reaching out to you shortly with your Learn K8s free offer. Any final thoughts, Rupak and Peter? Thank you so much for the wonderful explanation into the details of logging. Any final comments, and then we'll wrap up.
Nothing for me. Thanks, everybody. Rupak?
Rupak?
Nothing from me either.
Thank you, folks. Really appreciate all of you joining us today. We look forward to seeing you in the next webinar, which is a month from today. Thank you again, and have a great day.
Bye, everybody.
Thank you. Bye.